Hello everyone, welcome to GK StudyEdge. Today we are going to discuss gravitation. We have covered most of the important questions which are very common and repetitive in exams. We have particularly marked questions asked in SSC exams over the past 3 years. So let's begin the session. First question, who gave the law of gravitation? Isaac Newton gave the law of gravitation. He said that every object in this universe attracts every other object. Okay. What keeps Earth's atmosphere in place? Gravitation. Gravity holds everything together. If there was no gravity on Earth, everything would float away into space. Understood. Let's move on to next question. Which law explains about the tides due to the moon and the sun? Then the law is the law of gravitation. In 1687, Isaac Newton explained that the ocean tides are the result from the gravitational attraction of the moon and the sun. Okay. Next is the gravitational force of attraction between two bodies is dash the product of their masses. Before attempting this question, we must understand the law of gravitation in a little bit depth. So let's say there are two objects, m1 and m2, and they are separated by a distance r. So as per the law of gravitation, every object in this universe attracts every other object around it with a force. Okay, let's say the force here is F. The other part of the law says that the magnitude of this force F is directly proportional to the product of their masses. When we say product, it means m1 multiplied by m2. So here F is directly proportional to m1, m2. So let's go back to question again. The gravitational force of attraction, here it is F, between two bodies, let's say between m1 and m2, is the product of their masses. Now we know that F here is directly proportional to the product of the masses m1 and m2. So this is the answer. And the second part of the law also says that this F is inversely proportional to the square of the distance between them. So let's see this. The gravitational force of attraction between two bodies is inversely proportional to the square of the distance between the two bodies. Understood. Sometimes it is also asked in the exams that the gravitational force of attraction between two bodies is dash of the distance between the two bodies. Then your answer should be inversely proportional to the square of the distance. Understood. Let's move on to the next question. Next is the weight of an object on the moon is equal to dash of its weight on the earth. So answer is 1 by 6th, because moon's gravitation is equal to 1 by 6th of earth's gravitation. But why does it happen? We need to understand that. We know that the magnitude of the force of attraction is directly proportional to the mass of the object. And here, this is Earth and this is Moon. So you can clearly see that the mass of the Earth is much more than that of Moon. And because of that, the gravitational attraction exerted by Earth is much more than that of Moon. Understood? And this is the reason any object standing on the surface of the earth will experience more weight than on the surface of the moon. Understood? Because what is weight? Weight is the force with which an object is pulled towards the center of the earth or any other celestial body. So here the gravitational force exerted by the earth is more, and because of that the weight will increase, and here the gravitational force is less, and this is why the weight will be less. So we understood that when someone lands on moon, his weight will automatically decrease, and as we know that mass remains always unchanged. Next is a person can jump higher on the moon's surface than on the earth because the acceleration due to gravity in moon is smaller than on the earth. Acceleration due to gravity on earth is 9.8 meter per second square, and on the moon it is 1.625 meter per second square. Next is, according to the experiment conducted by Henry Cavendish in 1797-98, what was the value of universal gravitational constant? Henry Cavendish was the first person to experimentally determine the value of universal gravitational constant, and its value is 6.75 multiplied by 10 to the power minus 11 Newton meter square per kg square. And this value is constant, it doesn't change. And universal gravitational constant is denoted by G. Let's move on to next question. Which instrument was used to detect gravitational waves for the very first time? This is also a very important question. The answer is LIGO. LIGO stands for Laser Interferometer Gravitational Wave Observatory. It is actually a large-scale physics experiment and observatory to detect cosmic gravitational waves. Okay, let's move on to next question. Next is the slope of a velocity time graph represents what? It represents acceleration. Let's see how. Velocity, and here we draw time. Then the question says the slope of velocity time graph. This is the slope, and it represents what? It represents the acceleration. And why so? Let's understand. Here the velocity is changing with respect to time. And what is acceleration? The rate of change of velocity with respect to time is called acceleration. And that is why a velocity time graph always shows the acceleration of an object. Understood? Let's move on to next question. What is the value of acceleration due to gravity on the surface of Earth? We discussed it already. It is 9.8 meter per second square. Next is gravitational force or the weight of an object is maximum at which place? The answer is at poles, because acceleration due to gravity g is greater at poles than at equator. And we know that weight of an object is equal to m into g. M is mass, which is unchanged, and value of g determines the weight. Okay, but the real question is why g is higher at poles. Okay, so let's understand this. This is our Earth. This is not a perfect sphere, and its radius at equator is greater. As we move towards North Pole or South Pole, you will see that this radius is decreasing. Okay, and what is the relation between radius and acceleration due to gravity? Acceleration due to gravity g is inversely proportional to the square of the radius. So we can say if the radius is decreasing, the value of g will increase, and if the g will increase, it will automatically increase the weight of an object. And this is the reason weight of an object at the poles is highest. Okay. Next point is weight of a body is max at the poles. We just understood this, and 0 at the center of the earth, and mass remains constant. I hope you understood. Let's move on to next question. Next is if the acceleration due to gravity on the surface of earth is g, then the acceleration due to gravity on the surface of a planet whose mass is same as that of earth and radius is twice as that of earth is, answer is g by 4. Let's learn how to calculate it. We know that g is inversely proportional to the square of the radius. So we can write it. Let's calculate. Here in this question, it is asking us to calculate the acceleration of a planet, okay, whose radius is twice as that of Earth. So let's calculate. Let's say the new acceleration is g1. It will be equal to 1 by 2r square. Why 2r? Because the radius is twice as that of Earth. Okay. It will be 1 by 4r square. We know that 1 by r square, this is equal to g. Okay, so we can write g1 equal to g by 4. Okay, so this is the answer, g by 4. I hope you understood. This is very important, and this type of questions are frequently being asked in the exams. Only you will see that sometimes radius will be double, sometimes radius will be half, and they will ask you to calculate the acceleration of the planet or of any celestial body. Understood? Let's move on to next question. Next is, once a satellite has been launched into orbit, The only force governing its motion is the force of gravity. Let's understand it. This is our Earth and this is the satellite orbiting the Earth. Okay, to continue moving in a circular path, this satellite needs a force. This force is called centripetal force. Okay, and this force is always directed towards the center of the orbit. Okay, so here this centripetal force is produced by the gravitational force of this Earth. Okay, so here these gravitational force of Earth and centripetal force are not two different forces. They are the only one force, and that force is the gravitational force, the gravity of the Earth, and that is why the answer is gravity. Next is the reason of weightlessness in a satellite is due to zero reaction force due to the satellite surface, zero gravity, center of gravity, or there is no weightlessness anywhere. Let's understand it. Let's understand it. Suppose you are on the surface of the Earth. Due to gravity, all bodies are attracted towards the center of the Earth. We know it already, right? And the weight is due to the gravity. When we are being pulled towards the center of the Earth, it is the value of normal reaction exerted by the Earth's surface. Okay. This gives us the sensation of weight. We need to understand it. Okay. Let's see the condition of a satellite. A satellite is revolving around Earth in a circular path, and it is always in a free fall state, okay, along with the body, and therefore the normal reaction at any surface on the satellite is zero. And that is why an astronaut or anyone who is inside the satellite feels weightlessness. Okay, it is not because there is no gravity. Understood? Next is, who among the following was the first to conclude that in vacuum all objects fall with the same acceleration g and reach the ground at the same time? So Galileo Galilei was the first person to conclude that all objects, irrespective of its shape or weight, will fall with the same acceleration g and will hit the ground at the same time. In vacuum, a feather falls at the same rate as a ball. Galileo Galilei was from modern day Italy and has been called the father of observational astronomy and modern physics. Okay, let's move on to next question. Next question, under what condition a piece of paper and an iron ball will reach the ground at the same time when dropped from the same height? Just we discussed that in vacuum, everything will fall at the same rate. Okay, so here the most important condition is they must be dropped in vacuum. Understood? Let's move on to next question. Escape velocity at the Earth surface is, answer is 11.2 km per second, and escape velocity at the moon is 2.4 km per second. Okay. Who introduced laws of planetary motion? It's a very important question. The answer is Johannes Kepler. The laws which govern the motion of planets are called Kepler's laws. Next is, what do you understand by action at a distance force? So action at a distance forces are the forces which can act even when the bodies are not in the physical contact. For example, gravitational force, magnetic field. These forces are not in contact, yet they work. Next is, Europa is a natural satellite of Jupiter. Europa is a natural satellite of Jupiter and it was discovered by Galileo in 1610. Okay. Next is, what is the periodicity of Halley's Comet? Halley's Comet is actually a short period comet that is visible to the naked eye from Earth every 75 to 76 years. Okay. It was last appear in 1986 and will next appear in mid 2061. So that's it for today. We have discussed most important questions from gravitation. If you learned something valuable, please like the video, share with your friends and subscribe the channel. Thank you for watching. Have a nice day.